Continuing lesson 8.6, choosing appropriate statistical measures. This is on page 490. Page 490. If we look at the do you know how number 3, they want us to find the mean, median, and mode. So the first thing would be that we would need to put the numbers in order. So we put the numbers in order. That we'll need for finding the median in a minute. Before we do that, we'll go ahead and find the mean. Nice thing of finding the mean first. Then I know how many numbers I have. I know if I have just one middle number or two middle numbers when I find the median. So for the mean, if you add those numbers all together, you should get 351. You need to either show me that you're adding all the numbers together, or you need to at least show me this total of 351. And if you look at the numbers, we got a total of 9 numbers there. So 351 divided by 9 is 39. So this is our mean, is 39. And again, the nice thing about doing the mean first is now I know I've got 9 numbers, which means I have a middle number. So the median is going to have 4 numbers on either side of it, would be that 42 that I circled in red, boxed in red. Okay, so mean is 39, median is 42, and the mode, remember, is the one that occurs the most often. So the mode is 42 as well. Number 4 asks, is the median or mean the best measure of center? So what we talked about is that it's going to depend if we have an outlier or not. So as we look at our numbers, you might notice that we have an 18, and then we jump to 38, 39, 40, and so on. This 18 is really looking like an outlier to me. And if you remember, if we have an outlier, it's a better choice for us is going to be using the median. The median is not affected as much by the outlier. Okay, so here's that answer just to make sure everybody got that. Again, median is our best measure of center for this problem because it's not affected as much by that outlier of 18. We look at number 5. Find the measure of variability that best describes the data set. We talked about that when we use the median measure of variability, we will use the interquartile range, or IQR. So interquartile range, we would first have to figure out what the losing my numbers here. First have to figure out what the lower quartile and upper quartile are, or first quartile and third quartile. So these were our numbers. 42 is our median, and so you can see we got 4 numbers below, so we'd be averaging out 38 and 39, so 38.5 or 38.5 would be our lower quartile or first quartile. On the upper end, we'd be averaging out 43 and 44, so that'd be 43.5 or 43.5 would be our upper quartile. And then remember, to find the interquartile range, or IQR, we're just subtracting those two. So 43.5 minus 38.5 So a difference of 5. So for that last question, number 5, the interquartile range would be the best, and that interquartile range is 5. We look at workbook page 119. We have some information here, and they want us to make a dot plot of the data. Dot plot, not to be confused with box plot. Dot plot was the one where we put dots. So first thing, I went ahead and put the numbers in order at the top of the page here. Numbers in order, and then making a dot plot. Most of these are multiples of 5, so if you wanted to go by 5s, you could start with 125 going to 155, going by 5s. So this is our magical dot plot that just shows up. The numbers on these, notice we have 3 135s, so that needs 3 dots above it. The 154 is in between 150 and 155. That's one bad thing going by 5s here. We could put some little marks in between so we could tell better exactly what that is. And then the next thing, they ask us to find the mean, median, and mode. That's going to take a little bit of work here for us. Finding the mean, we're going to add them together and divide. So the mean should be $135.50. The median is the one in the middle, if there's one in the middle. We had 8 numbers here, so we actually have 2 middle numbers. So it ends up that the median is $135 as well. In the middle, we actually have 2 135s. Okay, 2 135s in the middle, so average 135 and 135, you get 135. And then the mode, obviously, the one that happened the most often there also was 135. The question, which measure best describes the center of these data, we want to look again and see about whether we have outliers or not. In this case, if we look at this, we kind of have a big cluster here on the side, and then we got this one over here. So that one does look like it is an outlier. So once again, if we have an outlier, our best choice is going to be the median. You might say, well, the mode is the same as the median. In this case, that's true. But again, the mode could be the highest or lowest number also. We never know what the mode's going to do, so it's not really predictable. So the median, if you have an outlier, just go with the median for that. So then if we look at number 3, which measure would you use to describe the variability of these data? Variability, since we used median, we're going to go with IQR again, interquartile range. Remember, if we go with the mean for a measure of center for variability, then we would use the mean absolute deviation, or MAD, which again, we haven't learned how to calculate, but just remember mean and mean absolute deviation go together for variability. And then number 4, describe the center and variability of these prices. We could kind of just go off of those things we just mentioned. So we could say that, by the center, we looked at the median. So we could say, talking about kick scooter prices, we could say a kick scooter typically costs around $135 at Ted's Sports. And then we could also say most of the prices are between $130 and $140. Okay, now the most prices between $130 and $140, that would be based off of the inner quartile range. So inner quartile range, again, we would look at, well, for the median, we had two middle numbers, so when we average them like that, remember when we average them, we don't count them So if we think maybe of these being the bottom four and these being the top four, something like that, then below the median, those four I just circled in blue, actually there's two in the middle which are both 130. Average of 130 and 130 is 130. On the upper end, we actually have four numbers there. And so I'm going to adjust this a little bit. This was the book's answer. If you look at that, we would be averaging a 135 and a 140 on that upper end. So that should be 137.50. Okay. Now, when we say that, we could, instead of most, we could say half. Another thing we could do is just kind of do a cluster mentality. Just generally looking at it without figuring the interquartile range, we could say, you know, besides the outlier, all the prices are between 125 and 140. Okay, so if we don't actually figure the interquartile range, that would be kind of a general statement we could make without working that out. Number 8, they want us to make a dot plot. They're asking us to find the mean, median, and mode, and then they're asking us if there are any outliers. So this one actually all goes multiples of 5, going from 50 to 80. So we'll just draw our magical dot plot again here. So here's what our dot plot would look like, and these are scattered around pretty good. You know, 80, there's one mark in between there, but it's not like way out there, so that's probably okay, where we would say probably there's no outlier on that. We could figure the mean, median, and mode. The mean looks like ends up being 61. Median is 60. And the mode, we could tell just looking, is 50. And like I said, there's really no outliers here. So if there's no outliers, on number 10, they're asking what would be the best measure of center. Well, no outliers. I'm going to go with the mean. Measure of center, I'll go with the mean. Again, if we were wanting the variability, we would go with the mean absolute deviation, or MAD. which again, you don't have to calculate at this point, but we do need to know that goes together. Number 11, they're asking what the outlier is in the data set. So outlier is either a lot smaller than the other numbers or a lot bigger. So we can see here $20 would be our outlier. Number 12, does an outlier affect the interquartile range? The numbers are in order here. There are 6 numbers, so in between 4 and 6, $5 would be our median. And then we've got 3 numbers below the median, so $2 would be our lower quartile or first quartile. Above the median we have 3 numbers, so $7 would be our upper quartile or third quartile. So interquartile range, we're just subtracting those, so interquartile range would be 5. And I know it didn't ask us to actually figure this, but just to mention to you about how this outlier doesn't necessarily affect the interquartile range too much. Basically, $20, it was the biggest number in our set here, but if you think about it, whether that was $20 or $200 or maybe it was $8, okay, if you can imagine if it was just $8 or $7.50, regardless, we don't really care when we're doing interquartile range, with it being the highest number in the set, doesn't really change that interquartile range. In other words, whether that was $20 or $8 or $1 million, our interquartile range for this problem would still be $5. And if we look at number 13, we have a table that shows the number of home runs hit by 8 baseball players. So first of all, they're asking if there are outliers. So we look at this pretty quickly. That 17 sticks out, so we'd say yes. In this case, the outlier is on the low end. 17 is quite a bit lower than the other numbers. Does the mean best describe the center? So remember, whether the mean best describes the center, that's going to depend if we have outliers or not. If we don't have outliers, all the numbers are pretty close, the mean will do a pretty good job. In this case, with our outlier, we would say no. And to be specific, we could say the median would be a better description. C, we could mention, I guess, the mean absolute deviation, whether that best describes the variability. Since we didn't choose mean, we would not choose mean absolute deviation. And then part D, does the interquartile range best describe the spread? And that answer would be yes. Remember, if we have median, we are going to use interquartile range. And a way to help you remember that, median has an I in it, and interquartile range does also. Okay, just a little trick there to maybe help you remember that those go together. And again, mean and mean absolute deviation, or MAD, are the other pair that go together. So this gives you an idea about choosing appropriate statistical measures.